Assalamu alaikum. We will continue with the second part of explanation carboxylic acid derivative. We reach to carboxylic acid converted to amide. Okay, for amide are difficult to prepare by direct reaction of carboxylic acid with amine because amine are base that converted the acid hydroxy of carboxylic acid, the acid OC double bond or OH, the H, the proton of carboxylic acid functional group. So this one is the amine is going to convert it because base, so going to take the proton, so going to convert the carboxylic acid to the carboxylate anion. This one is going to deactivate the carboxylic acid reactivity. However, so usually they use the catalyst DCC, dicyclohexyl carbodiamide, to activate the carboxylic acid before adding the amine to get the reaction between the carboxylic acid and amine in order to produce the amide. However, the mechanism in general going to be like, first the DSCC, the catalyst, is going to attack the proton of carboxylic acid. This is the H, the acid H of carboxylic acid. After is getting this, the proton is outside of carboxylic acid, then the carboxylic acid is going to get the negative charge. This negative charge is going to attack again the carbon of carbodiamine of the catalyst. This one is the catalyst of DCC, the carbon of DCC. Then there is rearrangement is going to happen and getting the compound is together. This compound, which is going to be the catalyst and the carboxylic acid. This one is going to get partial positive of carbon of the carbonyl. Now is easy to attack by any amino group, the electron pair on the nitrogen. After is getting attack the carbon of carbonyl, then we getting this structure, this one, which is going to be the catalyst and the carboxylic acid and the amine all together. Now the amine is getting one additional bond, so of course this one additional bond is going to appear the positive charge on the nitrogen because it's 4 bond, and the double bond is going to open toward the oxygen to get the negative charge on the oxygen. This one is not stable. Intermediate is going to get more stable by getting rearrangement for the mine anion toward the carbon of the carbonyl, and one of the bonds should be broken, which is going to be the oxygen of the catalyst that bond into the catalyst DSCC usually is good leaving group. In the end, after blocking this one, so you will get the amide and urea. So the catalyst is going to convert it to urea and the amide, the target compound that we want. This is the general mechanism of converted carboxylic acid to amide. So usually, again, first the initial step is the DCC. The catalyst is attack the acid proton of the carboxylic acid. After that is getting carboxylic anion. The carboxylic anion is going to attack the carbon of imine, the carbon of carbodiamide of the catalyst DCC to get intermediate compound contain the catalyst and carboxylic acid. After getting this compound, now the electron pair of amine can easily attack the carbon of carboxylic acid compound. And let me use the blue color. After that, we will get the intermediate contain all the compound is together with the catalyst amine, catalyst TCC, and carboxylic acid. This one going to rearrangement because the anion charged on the oxygen. After that, after open or after attack to get double bond with the carbon, should be another bond broken. So the one is going to broken is the catalyst one because it's good leaving a group. Then in the end is getting amide and the catalyst again. Now another one is conversion of carboxylic acid into alcohol. As we know, there is a lot of reduction catalysts like the hydrogenation using the platinum or nickel, or using lithium aluminum hydride, or using boron hydrate, or sodium borohydrate, or sodium cyanohydrate, sodium borocyanohydrate, all these catalysts. There is some feature for each of these catalysts. The first one, let me say for the lithium aluminum hydride. For lithium aluminum hydride, usually when I use this catalyst is going to convert it all the carboxylic acid, the nitrate to the carboxylic acid to alcohol and nitrate to amine. So this one is converted all the compound, all the C double bond, all the CN to the reduction one, the alcohol and amine. But when I use the BF3 in THF as a solvent with acid catalyst, this one is going to be selective to convert it just the carboxylic acid to alcohol. It will not convert it the amine. It will not convert it the nitron to amine, or the any compound derivative of amine usually to amine, any derivative of nitrogen to amine. So usually is working with the carboxylic acid or with aldehyde. This one is selective, so be careful. The borohydrate in THF solvent is going to be selective for carbonyl group. Is going to be selective for carbonyl group, not for amine derivative. These two catalysts usually that used for a carboxylic acid to convert it to alcohol. Okay. Now, preparation of acid halide. As we mentioned before, in the first part of carboxylic acid derivative, we can easily convert the hydroxyl group to halogen by using two agents. One is the famous one is the thionyl chloride. The second one is oxalyl chloride, and we already mentioned for the mechanism of this one. There is another one agent which is going to be expensive. That one is BBr3 to convert it to Br, halogen, acid bromide. The reaction of acid halide. The acid halide is more reactive because is more polar, and the Cl, this one is more electronegative and good leaving a group. So this compound acid halide is a very active compound. That's why it is easy to convert it to another carboxylic derivative. Like as we mentioned before, this one is easy to hydrolysis by water to get the carboxylic acid again, the partner compound, or react again with the salt of carboxylic acid to get anhydride, or react with alcohol to get ester, react with amine to get amide, or hydrolysis, reduction by hydrogenation to get aldehyde and then get alcohol. Again, here I mentioned second time, reduction of carboxylic acid derivative is getting aldehyde because it's terminal, and reaction of carboxylic acid derivative with any reagent, Grignard reagent, is going to give alcohol. Or ketone. Now for the carboxylic acid halide is going to give alcohol. We need to be careful with this one. Conversion of acid halide into acid is the mechanism of hydrolysis is just a general mechanism. The electron pair of water is going to attack the carbon of carbonyl then the bond of double bond oxygen is going to open forward oxygen. We will get negative charge on the oxygen and positive charge of oxygen from water. Then this one is going to broken by taking one hydrogen by base, and the chloride should be removed because there is 5 bond on the carbon, and the chloride is good leaving group, so it's easy to take it out. Then we will get this compound as intermediate. After that, the compound is just by taking the hydrogen by base, then we will get the carboxylic acid. Conversion of acid halide into anhydride. Acid halide into hydride, in addition to the previous method that we are saying, if there is 2 equivalent of carboxylic acid treated by high heating is going to get anhydride. The second method is react sodium or salt of carboxylic acid with acid chloride. So this one will take to get NaCl and the anhydride. This is the second method for preparation of anhydride. Conversion of acid halide into ester. This one usually is used by reacting of acid halide with any of alcohol. Usually is primary is more active than the secondary and tertiary because the steric hindrance. This reaction is present in this reaction can be done by present of acid as a catalyst, of base as a catalyst. So should be there is base to get this reaction in order to just remove or eliminate the Cl, because Cl is going to remove by the base. However, just keep in mind the primary is more reactive than secondary and tertiary in the preparation of ester by reacting of carboxylic acid and alcohol in the presence of base, while the main reason because of steric hindrance. Okay. Conversion of acid halide into amine. For this one, we don't need for DCC catalyst. DCC catalyst usually we use when there is carboxylic acid, C double bond OOH, because as I mentioned before, this proton, acid proton, is going to be attacked by amine, by base, and converted to carboxylic acid anion, and this one is not active, deactivate. Here we have Cl, which is, this compound is more active. Now this one is just direct taking with after react with amines getting NHCl, because this one is used as a catalyst and as a reactant. And the second amine, the second equivalent to the second mole of amine, is going to react with the carboxylic acid, with the carbon of carbonyl to get the amide. So the react of carboxylic acid halide with the amine, we don't need to use DCC as a catalyst. We need to use same compound as a catalyst. Base, we need to use base as catalyst. So usually we use 2 equivalent of amine. 2 equivalent. One equivalent is for reacted with the acid halide. The second one is for play as a catalyst. This is very famous reaction and more reactive reaction than the DCC, and more clean, high yield. So this is just an example for reaction of acid halide with the amine to get the amide. See, in this example, we use 1 equivalent of amine, and the second equivalent we use sodium hydroxide as a catalyst, which is going to be more base and more reactive than the morpholine. So the first one is going to attack the strong one with acid chloride to get the Cl out. After that, this is amine is going to attack the carbonyl to get the amide compound. Converted of acetic chloride into alcohol. Into alcohol we have two options. Is either using for this reaction is either using sodium borohydride or using lithium aluminum hydride, which is more strong to get the alcohol, which is more strong reduction catalyst. This one is too easy. The second one is reaction of acetic chloride with organometallic. Same Grignard reaction, same with the previous. Here is just be careful. We need to use two molecules of RMGX Grignard reaction with the acetic chloride, and then this one the chloride is going to remove, and the carbonyl, the oxygen C double bond will go to convert it to OH, and two group of alkyl is going to attach to the carbon of carbonyl. That means there is two additional group is going to attach to the carbon of carbonyl. Again, the reaction of acetic chloride with organometallic, the Grignard reaction or Grignard reagent, is getting alcohol compound with two additional group. For Gell-Mann reaction, that as previously taken in halide alkene, is RCU lithium. This reagent is giving one. The carbonyl group is going to be remain. It's just Cl is getting out, and the final compound is getting just one additional group of alkyl. So this is the two different. We need to be careful with these two reactions. The first one is a Grignard is getting alcohol with two additional carbon alkyl group. With the acidic chloride Gell-Mann reagent R2Cu lithium, copper lithium, we're getting acid. The same, the acidic chloride is going to be just remove the chloride, the carbonyl is going to remain with one additional R. So this one is giving ketone. If we want to convert it ketone, the carboxylic acid to ketone, we use Gell-Mann reagent. Let me take one example. Let me say, if I bring any question saying prepare ketone from the carboxylic acid, RC double bond OH. How to prepare the ketone from this compound? We need to use first, we need to convert this one to acidic chloride by using thionyl chloride. Then we will get RC double bond OCl. After that, we need to use Gell-Mann reagent, R2Cu lithium. Then we will get the final compound C double bond OR. Okay, I hope this one is going to be clear. Now okay, until here is going to end of the second part, because the first part I don't want to make it so large in the size that's going to get difficult for download. We will continue with the third part in chemistry of acid anhydride. See you.